Hello again to another Agakala React, and today we will be watching what would happen if the Earth had rings from Joe Scott. You know, rings like Saturn have rings, and wait, there's one more planet that have rings, isn't it? Is it Neptune? Ah, never mind, Saturn. Or I might be watching too many science fiction things, and there might be a few that they have rings and stuff like that. So let's just see to it.
This is planet Earth, and this is Saturn.
Yes.
And while Earth has a lot of things going for it, liquid water, life, the Poughkeepsie Civic Center, it's Saturn that's considered the jewel of the solar system. Probably because it has actual jewelry. It has a ring on it. But Saturn's not alone. Turns out all the gas giants
Uranus,
in the solar
Neptune,
system have
Jupiter
rings.
as well. Yeah, I
So
was
do some
thinking
dwarf
that.
planets like Haumea, Chariklo, and Korar. It's also thought that someday Mars will
Sorry,
have
what was that?
and a lot of scientists on it. But Saturn's not alone. Turns out all the gas giants in the solar system have rings. So do some dwarf planets like Haumea, Chariklo, and Korar. It's also thought that someday Mars will have rings. And a lot of scientists believe that there's another planet that used to have rings. Earth. Guys, the Earth used to have rings. So I came upon that little fact, and I've just kind of been obsessed with it ever since then. You know, like what would that look like? What would that mean? What if they were still here? To find the answer, I took a deep dive into this topic, devouring research, consulted with other Earth and space YouTubers, even reached out to one of the world's foremost planetary rings experts. And then I hired an award-winning visual effects artist to put together what I hope to be the single most scientifically accurate look at what the world would be like if the Earth still had rings. So before we talk about how a ring system around Earth would work, maybe we should start by talking about how rings work in the first place. Rings are, simply put, thousands and millions of tiny little rock and ice particles from the size of a grain of sand up to small moons. Moonlets, if you will. These usually stem from some kind of collision or gravitational forces tearing a moon apart, or sometimes an asteroid or a large comet. Yeah, in a way, rings are basically just like a giant debris field that never quite falls down. In fact, you can see in this animation of a satellite collision that took place in 2009 how the various debris fields kind of spread out into long, thin lines as it continues to orbit around the Earth, forming, temporarily anyway, a kind of ring. The physics of why the rings flatten out and usually settle around the equator are very complicated. It has a lot to do with...
I'm sorry, did he just say that actually happened?
It's so debris fields kind of, or sometimes an asteroid or a large comet. Yeah, in a way, rings are basically just like a giant debris field that never quite falls down. In fact, you can see in this animation
he said that
of a satellite collision that took place in
satellites go. Predicted debris trajectory statistical model. What the...
2009,
Never
how
heard
various
about it.
debris fields kind of spread out into long, thin lines as it continues to orbit around the Earth, forming, temporarily anyway, a kind of ring. The physics of why the rings flatten out and usually settle around the equator are very complicated. It has a lot to do with angular momentum and gravitational frames. In fact, it's so complicated that we're still learning things about it. Yeah, I mentioned earlier that some dwarf planets have rings. Well, the one around Korar was just discovered this last February. Korar is a dwarf planet in the Kuiper Belt, but its ring really made astronomers' heads explode because it kind of breaks all the rules. Like, it was thought that rings could only exist really close up to a planetary body because of the tidal forces that stop them from clumping up, but Korar's rings are like twice as far out as they should be. By the way, I mentioned earlier that Mars may have rings one day. That's because its moon Phobos is slowly moving closer to the planet. In about 50 million years or so, it'll get close enough for Mars's gravity to break it apart. So that's one way that rings can form. Another way that rings can form is from massive collisions, which brings us back to Earth. As you're probably well aware, the most accepted theory of how the moon was formed is the Theia giant impact hypothesis, which says a collision between Earth and a protoplanet named Theia created the moon. But before the moon, there were rings. They formed from the debris that got launched into orbit, some of which got sucked into the moon, some of it fell back to Earth, but it's thought that the rings lasted for millennia. But what if they were still around? What if during the entire history of the Earth, the origin of life, the dinosaurs, the entire history of humanity and civilization, the sky was adorned with rings? How would things be different? How would we be different? Let's start with exactly how these rings would look. First of all, they wouldn't look like Saturn's rings. Saturn's rings are a mixture of rock and ice. Lots of ice, actually. That's why they're so shiny. But Earth's rings wouldn't have all that ice simply because we're too close to the sun. Our rings would be more rocky and dusty. Wouldn't be
Makes
quite
sense.
as shiny as the icy rings of Saturn, but they would still be pretty shiny because they're so close. According to Columbia University Director of Astrobiology Caleb Scharf, the moon only reflects 12% of light from the sun, which is kind of amazing when you think about how bright a full moon is. But he took that basically as a starting point, and he speculated what a ring system would look like if it only reflected 10% of sunlight. And in a Live Science article, he said, quote, about 1,300 watts of sunlight per square meter hits the top of Earth's atmosphere. So 10% of that would produce as much as a 130-watt light bulb. That's per square meter. So he mentions the top of the atmosphere because there is a certain point under which there's enough atmosphere that it would create drag and eventually drag the rocks, into the planet and turn it into a meteor, basically. That level is at about 1,000 kilometers. And that's good news for satellites. Most of the satellites we put up there, including the ISS, that's all below the 1,000-kilometer mark. Some, geostationary satellites would have to go up past that. We'll get into all that here in a minute. So the rings would start at about 1,000 kilometers above sea level. How far they could go out, in theory, they could go out to the Roche limit. The Roche limit is basically the minimum distance that an object can approach a planet before the gravity of that planet tears it apart. Like I mentioned earlier that the Mars moon Phobos is going to eventually turn into rings, that's because it will eventually hit the Roche limit. So the deal is, outside the Roche limit, objects and debris will clump up into small moons. And this is actually what happened to our moon. Enough debris from the Theia collision went outside the Roche limit, and it just mooned up. Okay, so calculating the Roche limit for Earth is pretty complicated. It depends on a lot of different factors, but in some of the research that I did, I found that a general rule of thumb for comets anyway is 2.8 Earth radii, meaning that a passing comet will shatter if it gets inside 2.8 Earth radii, or about 17,880 kilometers. But I ran this past a couple of astronomers, including friend of the channel, Christian Reddy from Launchpad Astronomy, and the consensus seems to be that our rocky rings would probably have a little bit tighter Roche limit than an icy comet would, putting it somewhere around, say, 15,000 kilometers. So, roughly speaking, Earth's rings would exist in a kind of ring zone between 1,000 and 15,000 kilometers above the surface, most likely anchored above the equator where the orbital speed is highest. Now, depending on how the rings form, they could take up a little bit or all of that zone. If, say, it was just a captured asteroid or a comet, it might just be a thin ring, and it could exist anywhere inside that zone. But that's not how the Earth got its rings back in the day. Our rings came from a cataclysmic collision between two planets. That is not a small amount of debris. So in our case, our rings would have been big and full, kind of more like Saturn's rings, just out there, just spinning like a record baby right round, round, round. So with all those factors in mind, our ringed Earth would look something like this.
Wow. Hello, Shadow.
Now, all that's beautiful, but obviously we wouldn't experience the rings from that outside vantage point, not very often anyway. We would experience them from the ground, and that experience would vary depending on where you are on Earth. From the equator, it would barely look like rings at all. You would just see a line from one horizon to the opposite horizon. As you move away from the equator, say Mexico City, the rings would widen and arc across the sky to the south, taking up a large section of the sky. Moving further north to New York, and you probably wouldn't see the bottom of the rings at all due to the curvature of the Earth. They would just exist in a permanent rainbow across the southern sky. And as you approach the North Pole, the rings would barely be visible, if they're visible at all. They would just exist basically as a permanent twilight effect. The rings would be visible at all times of the day, barring overcast skies, of course, but it's at night when it gets really interesting. Because, imagine the brightness of the full moon, but way closer and, all the way across the sky. You never really have night like we have now. But again, that depends on where you are. Back at the equator, you just see a bright line from one horizon to the other, giving you mostly the same view you get now, depending on the time of year, which we'll get to in a second. Same goes for the poles, which would be almost identical to the sky above the poles right now with their long periods of light and dark. But in the middle to the upper latitudes, that's where you get a real show. Nighttime in these areas would be so bright you might not even need headlights on cars. The rings would dominate the sky and far outshine the moon, which would appear like a dull, dark orb in contrast with the rings.
That's so
the rings would be by far the defining feature of the night sky, but the defining feature of the rings would be the Earth's shadow.
Yeah.
In fact, you'd never see the full rings at night. As the sun sets in the west, the Earth's shadow would begin to appear in the east.
Shadow, stop
slowly
scratching the
moving
monitor.
across the sky throughout the night, so that by the time it
That's
disappears on the
so
western
cool.
horizon, the sun would begin to light up the sky in the east again. This would make timekeeping at night super easy because you'd be able to tell with just a quick glance but where the shadow is across the rings, what time it is. You know, again, barring an overcast sky. And that shadow would vary greatly according to the seasons. From the summer to winter solstice, you'd see the Earth's shadow grow, taking up more and more of the rings thanks to that 23.5 degree tilt of the Earth as it moves around the sun. But it's not just the Earth's rings on the shadow that would change throughout the seasons, it's also the ring's shadow on the Earth. And this is actually a much more important thing to talk about. Because those rings would make the seasons vastly more extreme, with hotter summers and way colder winters. Because in the summers, the sun would shine directly on, say, the northern hemisphere, but the southern hemisphere would be shrouded in darkness. And as the Earth moves around the sun, the opposite would become true. Meaning we would have very dark winters that last up to 6 months. Now, granted, it might not be nighttime dark. It's doubtful the rings would block all the light, but it would serve like almost like a window tint over the Earth, just reducing the amount of light hitting the surface.
Stop scratching
Less
my phone!
and
What
less
is you
heat,
scratching today?
leading to brutally cold winters. Possibly warmer summers, because you wouldn't just be getting the light from the sun, you'd be getting all that light reflected off of the rings as well. In fact, there might be like a moving band across the Earth where the reflection off the rings would basically focus the light in one spot, making it extremely intense. From the ground, it could almost look like two suns in the sky, creating a Tatooine effect. Now, around the equator, you'd probably start to see some really crazy effects in the spring and fall, because as those rings go more edge-on, the amount of light being blocked would increase, and the shadows would become darker, meaning that the people living in the shadow would basically be in permanent night for a couple of months. So right on the equator, as the year goes by, you'd see the sun move in that familiar analemma figure 8, with the sun crossing the rings at the spring
Scratch
and
me again.
months. Further north in Mexico City, things get more interesting, with a typical summer and fall leading to a dark, long, 15-week winter, with the sun going behind the rings around the end of October and not coming back
What you
out
doing to this lamp now?
It would be a
Sorry
similar
guys,
situation
Shadow is
in
just
New
being
York,
a
except
berserker
due to the
today.
higher
Hey.
latitude, the sun would only
Behave.
spend 8 weeks behind the rings, going behind around the 23rd of November and emerging around the 18th of January. Meaning Mexico City would actually have a longer and darker winter than New York, though the already colder temperatures in New York would make their dark days much more brutal. So yeah, a ringed Earth would be pretty. It would make for some pretty fantastic landscape portraits, but it would make a very significant impact on the world. Like, living on a ringed Earth would just be very different from what we're used to now. Of course, if we evolved there, we'd think nothing of it. We'd not only be used to it, we would have been created by it. Like, our circadian rhythms would be vastly different to deal with the very bright summers and very, very long, dark winters. Plants and animals might be stouter and chunkier to kind of deal with the long, cold months. We might be a bit more stocky. Now, we can only speculate how we and other plants and animals would evolve differently under a ringed Earth, but the real fun speculation comes when you start thinking about how these rings would affect our culture. Yeah, what are all the different ways we'll find to kill each other over these rings? It would be immense.
Yeah.
I mean, like, just think about how much the moon has influenced culture, and that's just a dot in the sky. Like, I'm releasing this video on a Monday. It's the middle of the month. People tend to get a little crazier around full moons. That's why we call crazy people lunatics. The moon is all over our art and our literature, even our religion. The presence of rings that would be brighter and more constant than the moon would dominate all three. Speaking of the moon, would that mess up the rings? Turns out this is a topic of much debate. Because on one hand, the moon is way, way further away than the rings are. The moon is 400,000 kilometers away. That's much further away than 15,000. But the moon does still exert a gravitational force on the planet. I mean, just look at the tides. But again, oceans of water are a vastly different medium than an accretion disk of particulate dust orbiting in space. I mean, just look at all the satellites that we've launched around the Earth, and they're not affected by the moon's gravity. So in my research for this video, I ran across a scientific paper from 2016 titled Planetary Ring Dynamics from Boltzmann Equation to Celestial Mechanics by astronomer Pierre-Yves Longoretti. And so, I reached out to him. And he was kind enough to respond to me, and one of his initial concerns was the difference between the orbital plane of the rings versus the orbital plane of the moon. Because, as my shirt illustrates here, the Earth is tilted at 23.5 degrees, but the moon orbits on the same plane as the Earth's orbit around the sun, meaning it's not lined up with the equator the way that the rings would be. So let's just say this little ball here is the moon. It would be orbiting in this direction, and when it's on this side of the planet, it would pull down on the rings. Where it's on this side of the planet, it would pull up on the rings. This is not in proportion whatsoever. It would actually be like way out here. My arm's not long enough. The point is, this could, over hundreds of millions of years, be a destabilizing force on the rings. Especially if the rings were created during the Theia collision, this might be why they're not around anymore, because the moon was a lot closer back then and would have had a stronger effect on them. So one could make the argument that in order for us to have the rings, we couldn't have a moon. But then you get into the whole debate as to whether or not life could have even formed on the Earth without the stabilizing effect of the moon over the years. So yeah, it's a complicated question. At the very least, the moon would have disrupted the rings a little bit to cause like spokes and spikes in the rings, but kind of like what we see on Saturn. Anyway, back to culture. Some of the earliest prehistoric structures that we found tend to be astronomical in nature, often observing dates like the summer solstice. Like I did a video earlier this year on this place called the Chanquillo Archaeoastronomical Complex. It's a prime example of structures meant to mark the position of the sun. And I think you can see a similar kind of building and observation of the days that the sun goes behind the rings and when it comes back out, especially since those mark the transition from drastically different seasons for our ringed Earth people. You know, they might see the rings as a kind of road or in-between world between life and death. Like that's where you go where you die. And if they worship the sun, that day might be the day that the sun god takes in all the souls of those who died in the last year. You could expect that cultures would be really divided along latitude lines because of how differently they would experience the rings. They might also observe the dates when the rings disconnect and then reconnect in the night sky because of the Earth's shadow breaking them up. The rings might be the land of the gods. If the moon did stir up, you know, the rings and create little patterns in it, maybe they would interpret those patterns as different gods. Though the patterns might change too much, they may not last long enough for whole religions to come out of them. Then again, if they did stir up a lot, you know, people being the pattern seekers that we are, we'd probably look for signs in the rings. You know, what we call astrology, they might have people whose job it is to read the signs in the rings, you know, psychics and priests and prognosticators.
But how?
Or maybe ancient ringed earthers thought that the rings were where, you know, water fell off the edge. You know, think of how explorers would have felt when they reached the equator and found that the world just kept on going. Of course, the people who lived at the equator would have their own explanations for all that. To them, the ring might be more of a boundary, just dividing the sky into two halves. They might be about the twin pantheons, maybe male on one side, female on the other. Actually, I think a lot of the ring mythology might be about pairs and maybe fertility. But myth is not the only aspect of culture that would have been affected by the rings. Science would have benefited in some ways and hindered in others. On the benefit side, timekeeping would have been easier. The ring's shadows would have moved in predictable ways as the Earth revolved around the sun. Navigational scientists would have benefited from that. Like, good luck losing your direction on a ringed Earth. South would always be ring side and north might be sky side. Everywhere in the northern hemisphere, vice versa in the southern hemisphere, of course. Astronomy would be both hindered and helped by the rings. On one hand, obviously it would block large parts of the sky. The brightness of the summer months would make astronomical observations really difficult. But on the other hand, some think that having rings would have created an earlier understanding of the nature of gravity in the solar system, maybe even aided with determining the distances to the stars. We might have been a spacefaring civilization 1,000 years ago. Or maybe not.
No.
In fact, we might not ever be able to leave a ringed Earth. Orbiting gets kind of hard when there's, you know, rings there. Now granted, most of the satellites that we currently orbit are between 500 and 2,000 kilometers, so we could definitely get a lot of payload up there in the area below the rings. Geostationary orbit would be like twice as far out as our rings, so they'd be safe. And there's actually plenty of medium Earth orbit, or MEO, that would easily clear the rings. But getting them out beyond the rings, that would be trickier. Not impossible,
Just
but
tricky.
trickier. I will say this, a lot of astronauts talk about how they go up to space because they love space and whatnot, but once they get up there, they look up and all they see is blackness and emptiness, and then they find themselves staring down at Earth the whole time. Kind of the astronaut's paradox, if you will. That would not be the case if there were rings. I imagine the views out into space over those rings would be spectacular. Especially if you're orbiting the Earth every 90 minutes. That means once every 45 minutes you might fly past the rings. It would be hard not to stare as these rings come flying toward you. I imagine that would be an amazing sight. So they think the Earth once had rings. It's kind of impossible to know how big they might have been. It might not have been anything at all like what we talked about here. I, for one, would kind of hope that they were smaller and not quite as big as what I'm just talking about. I mean, a tiny thin ring would still be cool, but it wouldn't have all the temperature and weather effects that those large Saturn-like rings would have. Now, before I close this up, I feel like I should be super pedantic and point out that, you know, some might argue that we actually do have rings right now. Lots of them, actually. The rings being the orbits of those satellites I was just talking about. Because there are certain orbital corridors that satellites tend to follow, especially in geostationary satellites. As you can see, things get pretty chaotic around low Earth orbit, but in higher up orbits, they tend to form rings. Some go in different directions than the equatorial rings that we imagine, but the geostationary orbits,
Whoa!
I mean, if that's not a ring, I don't know what it is. Now, obviously, some of these rings are things that we don't really want. Space junk is a problem. Most of them are low enough to come down eventually, like I said, under the 1,000-kilometer level where the atmospheric drag would pull it down. But it is still a problem. I did an interview on my podcast a while back with Mariba Jha, a space environmentalist, about the problem of space junk. I recommend you go listen to that. I found it enlightening. Okay, so I set out to make the most scientifically accurate look at the Earth with rings that is humanly possible. And the fact of the matter is, when it all comes down to it, rings would have a really difficult time around Earth. So I mentioned my email exchange earlier with Pierre Longoretti. He had that concern about what the moon's effect on the rings would be. Well, there was another effect that could also be a problem. The Earth itself. Because unlike the gas giants that all have these big, beautiful rings, the Earth is not perfectly round, and the distribution of the mass in the Earth isn't perfect either, as this gravitational map from NASA's GRACE satellite shows. So it's possible that all these gravitational aberrations on Earth might, stir up the rings even more than the moon would. Which, again, could create spikes and spokes in the rings at the least, and at the most, it might destabilize the whole thing entirely. So perhaps in the end, after all of this, the most scientifically accurate view of a ringed Earth is an Earth without rings. And actually, that's okay. Because those same Earth conditions that may not be suitable for rings were the conditions that made life on Earth possible.
Mm-hmm.
And life's pretty great too. So I guess, for a planet to both have life and rings, that's just, it's too much of a good thing. Like subscriptions are a good thing. Like having access to a service, having food delivered to your door, medicine that helps you to live better, that's a good thing. But if you have too many, it adds up. And that is too much of a good thing. Like, I recently found out that I'm actually paying twice for HBO Max. I signed up accidentally through 2 different services. I don't know, but
How can you?
I barely even watch it. And I would not have known that if it wasn't for today's sponsor, Rocket Money. This is a service that could rocket your money beyond the rings. Metaphorically, it's not going to put it in a rocket. It's not going to do that. Rocket Money is an all-in-one platform that helps you keep more of your money. And it does this a few ways. One, it keeps track of all those subscriptions. It's actually kind of scary when you realize how many things in your life just kind of take money out of your bank account every month. I bet at least 80% of you are paying a subscription on something every month and you don't even know it. But Rocket Money will go out and find all your subscriptions, and then it keeps track of them so that you can keep the ones that you want, get rid of the ones you don't. 2, it helps you to keep track of your spending in an easy and intuitive way, so you don't have to dig through all the spreadsheets and tables. It just shows you spent this much on coffee this month or this much on eating out, because you can't change what you don't measure. And 3, it'll take that money and it'll automatically put it into savings, where it can grow and give you a nice little cushion. Because we can all use a little cushion. And it does other things too. It can keep track of your credit and let you know when that takes a hit. It can help you set budgets and basically just gives you a tool to put all your financial entanglements together so you can make smarter decisions. A lot of people feel like they're not really good with money, but the problem is they don't have good information. Even the best general's got to know where all of his troops are on the battlefield if he wants to win the battle. Battle for your wallet. Over 5 million people are using Rocket Money to help them spend less and save more, and in the spirit of spending less, you can get started for free when you go to rocketmoney.com/Joe Scott. It doesn't cost you anything, it'll show you what you can save, and if you want to open up more premium features, there's a premium version too. I think you'll find it pays for itself. So go give it a try, that's rocketmoney.com/Joe Scott, links down in the description, just give it a click, check it out. Alright, big thanks to the Answer Files on Patreon and the channel members who are helping to support this channel, helping to keep the lights on around here, forming an awesome community, a great sounding board for all these ideas. I get a lot of my ideas from my Patreon members. But anyway, we've got some new people I need to shout out real quick. We've got Daksh Desai, Richard Gildart, Richard Jones, Kelly Ann, Nancy Colwell-Miller, Gary Oliver, Matthew Mercer, who is apparently somebody that my assistant Kimmy is a giant fan of. She's a voice actor, so she's really excited to have you on here. Cool, buddy. Marco Curran, Anna Pascone, and Darth Heathy. Thank you guys so much. If you would like to join them, get early access to videos, and hang out with Matthew Mercer, apparently, just go to patreon.com/answerswithjoe. Alright, please do like and share this video if you liked it, and if this is your first time here, I'll put a video right here you can go check out, and if you like that one, or any of the others that have my face and the thumbnails and the stuff, I do invite you to subscribe. I come back with videos every Monday. Alright, thanks again for watching. You guys go out there, have an eye-opening rest of the week, stay safe, avoid those rings, and I'll see you next Monday. Love you guys. Take care.
That was very well done. Do have to say it. It would be amazing to see those rings around the Earth. But then, yeah, he's right about the whole thing about, are they needed? I don't think so. where they need it, everything would look totally different, because honestly, like he did mention, it would probably be slightly different. Evolution will take a slightly different route. We would be looking a bit different. And but damn, those views, they were good. The night sky, chef's kiss. That was very well done. Yeah. So, if you like this video, go to the description below and go into the link, because that's where you can find the link. Or you might be already subscribed to Joe Scott. I'm definitely gonna subscribe as well. And thank you very much for watching. I'll see you tomorrow. Bye.